Okay, so today we're going to be looking at chapter 3.8, homework question number 15. This is dealing with the moments, okay, the moment about x and the moment about y. Okay, so in this problem we have our function f of x equals x, which is this straight line here. We have our function g of x equals x squared, which is our parabola here. And we're looking from x equals 0 to x equals 1. So that's this shaded region right here. Okay, so I want you to call attention. We're going to be taking a look at where's the moment about x and the moment about y. We're also given an area density as a function of x, which is 2x plus 1. And that's nice because this is in terms of x, and everything that we have in terms of our functions is already in terms of x. So I don't have to do any kind of, like if this was in terms of y, I'd have to convert all of this to be f of y, and I'd have to be able to solve for it. Okay, so the first thing that we're asked is we want to be able to take a look at the mass. So the mass, remember, is a to b. We're going to integrate our area density times the area of this region that we're looking at. So in this particular case, we're going to go from 0 to 1 because we're going dx. Our delta area density is 2x plus 1. We were given that at the beginning. Our area of the region that we're working for right here is our top function, which is f of x, minus our bottom function, which is g of x. So f of x is equal to x, and our bottom function is equal to x squared. And this is as a function of dx. Remember, the area of this region is the top minus the bottom. So that's how we got this function right here. So I would FOIL these two up, and then I would do the power rule. So it's going to end up looking like from 0 to 1, 2x squared minus 2x cubed plus x minus x squared dx. And I'm going to get 1/3 x cubed minus 1/2 x to the 4th plus 1/2 x squared, and I'm going to go from 0 to 1, which is going to give me an overall mass of 1/3. We usually do the mass first because we're going to need that. We're going to need to divide by the mass because we're going to get the moment of x, which is our mass times the x, and the mass times the y. And if I divide each of these by m, by my mass, I'm going to be able to get my x and my y components. Okay, so now part B says, let's go ahead and get mx. So this is our moment about x. So I'm going to go from A to B. This is our area density times x, because it tells us where in the x we're talking about, and then the area that we're looking at. So in this case, this is f of x minus g of x times dx. Okay, so this is going to give us where, this is like our radius, right? Where along, what's our x coordinate along here? What's the density at that particular spot? And what's the area, the delta area that we're working with? Okay, so plugging everything in, I'm going to go from 0 to 1. My area density is 2x plus 1. I've got my x. Okay, and then I also have my function, x minus x squared dx. Okay, so this is the area between the two functions. This tells us our x coordinate along which, where is our mass actually located. So these two here are going to be talking about what's the specific mass location. Okay, so I've got my area density and I've got the x location about where that's happening. Okay, so I need to multiply everything through. If I multiply everything through, I'm going to get 0 to 1, x cubed minus 2x to the 4th plus x squared dx. Doing the power rule, I get 1/4 x to the 4th minus 2/5 x to the 5th plus 1/3 x cubed, 0 to 1. And when I add everything up, I'm going to get, that's equal to 11/60. And that gives me my m times x. Okay, so let's skip here to part D, which is my x bar. It's my x coordinate for my moment. Okay, my x moment. So I take my mx bar and I divide it by the mass. So I'm going to get 11/60 divided by 1/3, which gives me 11/20. Now I'll erase things, okay, so that then we can take a look at our moment about y, and then go ahead and get our y values. Okay, so I'll take out this part. And this part right here. Okay, So let's go ahead and take a look at, actually I'll erase this part here too. Okay, so let's go ahead and do our y. So this is part C. So this is my bar is going to equal to, we're going to go from A to B. This is our delta area function, okay, our area density function. Now, on our homework solutions, we have it written like this, f of x squared minus g of x squared all over to the, sorry, that's a squared, dx. But let's talk about where this is going to come from, okay? So where this comes from is, I'm going from A to B, delta area density, okay? My y component, like our x, when I just wrote down x, that was my x component, my y component is an average of the two y values. So this is f of x plus g of x divided by 2 gives me the average y component based on f of x and g of x, right? That's already multiplied by my area, which is the delta area here. The delta area we already established before, which was f of x minus g of x. Okay, this is dx. If I take out this 2, I'm going to get f of x plus g of x times f of x minus g of x. This is our difference of two perfect squares, right? So this looks like f of x squared minus g of x squared. This is our difference of squares in algebra. That's where this comes from. Okay, it's not some random thing, we're just dividing it by 2. This is our y component, and this is our area. Okay, dA times, this thing here times dx gives us the area. Okay, so when I plug everything in, I'm going to go from 0 to 1, that's my a to b. My delta area function is 2x plus 1. I'm going to multiply that by x squared minus x to the 4th divided by 2. This is my f of x, which is x squared. My g of x, which is x squared, squared, which is x fourth. The whole thing is divided by 2. Okay, dx. Okay, so now I get to FOIL these out, and then I get to actually do the power rule. So it's going to look like 1/2. I'll take the 1/2 out from 0 to 1. 2x cubed minus 2x to the 5th plus x squared minus x to the 4th dx. Okay, now I can go ahead and do the power rule on this, which is going to give me 1/2 times x to the 4th all over 2 minus x to the 6th all over 3 plus x cubed all over 3 minus x to the 5th all over 5. And I'm going to go from 0 to 1. When I put everything in, 0 and 1, and I subtract and I combine all my like terms, what I get for my my component is going to be equal to 3 all over 20. So using that to help me, this is part E, which just gives me just my y component of the moment. I'm going to take my mass times y divided by the mass. So I'm going to say 3 all over 20 divided by 1/3, which is going to end up giving me 9 all over 20.